All right. In my pocket. Good afternoon to everyone. I will be jumping right back in pretty much on the same thing that I worked on this past Saturday on the stream. So if you want to see the prequel to what you're about to watch, you can go find the VOD from this past Saturday. Although I did do a bit of work off stream, so you'll have kind of a gap, but you can kind of get caught up if you watch this one too. What I'm gonna start with specifically, actually let me lay out what the problem is, just the core problem we're trying to solve high level, and then we'll dive into what I'm trying to do to solve it right now. In order to do that, let me change this back to how it was before. Let's make a build, and let's put that on our device. So while that's building, I will fill you in a bit further. The core problem is basically related to color spaces and different color spaces used when you load a JPEG image file versus when you load a BMP image file, and then being able to blit a section, which is kind of like copy paste a section from one bitmap to another bitmap. If those two bitmaps have different color spaces, the blit, doesn't work how you would expect necessarily. It copies over the numbers that are inside of that bitmap, but those numbers mean different colors inside those two different bitmaps, or those two different bitmaps, although one of them could have come from a JPEG. Therefore, what you end up with as an image is maybe not what you would expect color-wise. So I'm trying to get it to where I can blit from a BMP source into what is ultimately a JPEG source, and have the colors of both look correct. So we got that loaded. Let me run the version that will do this. So I think the first thing that we'll do when I get into solving more so than showing is try to knock this down to something that runs faster. So right now, this code does what basically? It initializes the SD card so that we can interact with files that are stored on it. It loads up the JSON decoder. It opens a JPEG from the SD card. It decodes it into a bitmap. We actually need to swap these right now too, so let's do that. It decodes it into a bitmap. It prints the size of the bitmap. It opens the JPEG, which gives it the size. It creates an empty bitmap that it's gonna put that image into. It prints the size of that new bitmap it created. Then it calls decode, which is what's actually taking the stuff from the JPEG file that we opened and putting it into the bitmap object that we created there. So then we have a bitmap that represents what's in our JPEG. We next are loading up a new bitmap, this time with image load. This one is an actual bitmap, not a JPEG. It loads up this file, frame RGB 888. This file is full RGB 888 color. I created this. Is this being used right now? Yeah, it's being used right there. This is an 888 color converter, so this will take a color in the 888 color format, color language, whatever, color format, and then convert it to a 565 color. It prints out a particular pixel from the frame one. It calls blit. Destination is the photo, source is the frame, 00. Skip source index. So our skip source index, ordinarily you'd put an index on your palette. In this case, our images are not palettes. They are, they're not indexed colors, I should say, rather. They're RGB, so they don't use indexes and palettes. Instead, they use the color converter. So what I've kind of roughly done is said, like, green is my chroma key color, but I need to convert that green from, 888 normal hex 24-bit color down to what is effectively 565. And so that's what the color converter can help me do. So we can convert that green, tell it the 565 version of green is what we want to skip, which is the green that we have in this image here. It's trying to do that blip for us, and then it's outputting it to a file, which it saves on the SD card. And I kind of keep just incrementing this number out of superstition. It can actually overwrite the file just fine, and I could look at the old one again. But I like changing this number so that I know it wrote a new one, and I know that I'm looking at one that came from the latest version of the code. All right, so let's let that run once. It does take a minute, so I don't want to run this version that many times, really. One thing I need to do is import display.io, display.io.release display. So the SD card and the display interfere with each other. We need to release the display so that we don't have any trouble with the SD card. But then we can import convert photo. That should basically run our test right now. So that's going to run. It does take it a minute. Like I said, it takes quite a while, really, for it to finish. A smaller image would take less time, I think. We are using the biggest size image that the photo camera that I used could output, although I am also scaling it down when it gets decoded out of the JPEG. But I don't know if that's adding more time or taking time away or not impacting the amount of time it takes. My intention was to speed it up, but I'm not actually sure that it did that. And when this does finally finish, I'll go and show you the image of what we're getting kind of right now with stock CircuitPython, effectively. I have a modified version of CircuitPython where I was trying to just quickly hardcode hack in a change that would fix what I think the problem was, but it was not working how I thought. So we'll be back to the drawing board on that in a minute. But what I'll do before I really get back to the iteration of the problem solving on that is I will break this down to a much smaller thing so that we don't have to wait as long, hopefully, I think. Let's make a much smaller image. Let's just cut a piece of this one out, in fact. That's what, 60? I mean, that's still very big, honestly. I don't think we need all of that. Let's just make a new one that is only like, maybe like 30 by 10. Then we'll do 10, 10, and 10. And that's like pretty small, but I can kind of see it on the screen. I don't have the camera set up. You're not going to be able to see it on the screen. Most of the action's not going to be on the screen of the microcontroller. Most of the action's going to be on the screen of my computer anyway, because most of the time, we're not actually caring about the screen of the microcontroller. We're just saving a file, which I'll then open on my PC. 30 by 10, let's do that. Advanced, let's just throw in transparency for now. We can make a 10 by 10 of each color. So green, which is full on green, I believe. Yeah. Let's do green on the far edge, though, actually. We want green over here, though. This seems to have, like, moved my layer entirely, which I didn't really want, so I'm just going to go layer to image size to scoot that back. I'm going to select again. Somehow we still have this selected, so that's cool. I will make this, let's see, I want to pick the same colors that we have in this other one. Oh, interesting. That goes between files. Okay, so that's blue. Then pink we want as well. Can move this. All right, eventually we'll maybe even make this smaller still, but let's start with that. It's much smaller than what I'm working with now. You can see back here in the background, this did finally finish. I'm gonna save this as a smaller test file, RGB 888. We're gonna save that as BMP as well. Why was that on there, I wonder? All right, that's 1K instead of 900K. Let's just save that on the CircuitPy drive. All right, now let's go look. So it's the one we just saved. Okay, so this section here is from the camera, and while I will admit the colors look pretty strange, the colors are quote-unquote correct. Those are how they're supposed to appear. This frame, though, ideally is supposed to appear as pink and blue, and then the green, which is actually in the middle of the frame, that is the chroma key color, which gets omitted, which is why we're able to see the picture in the middle of the frame. Now, the picture is also scaled down right now because of this number here. Ultimately, we would have it to where the picture is full size and the frame is all the way around it, but one step at a time. So we're trying to fix the frame rendering, right? Why is this frame rendering as green and beige instead of blue and pink? Is effectively the root problem here. My last attempt at solving it was, I thought, converting from normal 565 color space to swapped 565 color space, which I thought was what I needed to do and might still be what we need to do, but when I did it, it resulted in this, which is even more wrong, obviously. I either did it wrong or it's not actually what we need. Yeah, one of those two things. Or maybe an interesting and surprising third thing, even, I suppose, is a possibility. So, and when I was doing this, I was just very hackily hard coding a change inside of, this is in the core inside of Bitmap Tools Blit. Because my kind of working theory here is that my colors, which are in frame, colors that are in this frame BMP, so the colors in the actual file are 888. That's what we saved from GIMP just a second ago. I believe that's what I also saved in the frame. But it is set up to use a 888 color converter, which is making it so that effectively the colors come out as 565. So I printed 5050 right here, which is inside the frame. So 5050 is green, and in the 888 color space, it's 00FF00. So I told it to print 5050 of the BMP, and what we got was 2016, which at first seems a little weird, but if we hexify that, 2016 is 7E0, And hug report, I should put that in for next week. Yeah, my bad on that one also. Belated hug report goes to DJ Devin for sharing this this page, which is actually pretty awesome for sure. This page lets you figure stuff out, like the fact that (24-bit green 00FF00) when converted into 565 is actually equal to hex 07E0, which is 2016. I guess the leading 0 doesn't matter? Yeah. Like a silent leading 0. Okay, so when we access pixels from CircuitPython land, they are automatically getting converted from the 888, which actually exists in the file, to 565. But then when they get stuck into the photo bitmap with blit, they are gonna then be under the color rules of the photo bitmap, which is actually technically this RGB 565 swapped, which ultimately came from the JPEG decoding. So JPEG decodes it into 565 swapped by using the save pixels here and specifying color converter RGB 565 swapped. We're making it so that when we output that photo bitmap to the disk, it is accounting for the fact that those colors, which came from the JPEG, are in that 565 swapped. But it's not accounting for the fact when it blits from the frame, it's not accounting for the fact that the frame technically, I think, is in 565 regular, not 565 swapped, although it starts life with 888. When it actually gets accessed, it's accessed as 565 non-swapped. I think it needs to convert it to 565 swapped because that's the color space of the photo bitmap, which is where we're putting it into. Okay, so that was kind of long-winded. If anybody happens to be watching with questions or wants more clarification, try to let me know, and I'm happy to do that. But I also just wanted to get everything out for my own sake, just as a bit of a rubber duck exercise, get my head wrapped around where we're at right now. So let's start changing this to use a much smaller file. Do I even need the JPEG? Let's think about this for a minute. Do I need the JPEG? I don't think I do. I don't think that we actually do need the JPEG. I have another file, blit test, where I was doing a different one of these tests. Yeah, let's try this. So I copied in, what was that other file that was smaller test file. So let's do this. Frame, we'll just leave it as frame, even though it's not the frame anymore. Smaller, it doesn't want to do that, I guess. Smaller, maybe it doesn't like the slash. Does not want to, oh, there it goes, okay. It probably would not need the slash there, I guess, I don't know. Let's try without. Open that one. This is in 888. Yes, so color converter is there. Okay, main group. So let's make a destination bitmap that's 10 pixels. and then we blit from the frame into the destination bitmap. We're blitting. Your 0 is the location, and then we're blitting as 3x3 square, or perhaps 2x2. I don't know how the edges work off the top of my head. We are making a destination tile grid, which in this case is using a pixel shader of 565 swapped. It is printing those again. It created a photo tile grid from the frame. If anything, I think we want to make that from the destination. Truthfully, I don't know that we really need to make the tile grid at all because we don't necessarily need to show it on the screen at all. Oh, that's the photo. So we have a destination tile grid. That's the photo tile grid. Let's just, well, but it's weird that it's making it from the frame. I guess I just swapped it in from some other code. That's fine. Let's just comment that out. Main group append destination tile grid. So that's happening already. Okay, let's blit a bigger section. Let's say, let's just do the whole thing. It's not super duper huge. Let's just do the whole thing for now. We're blitting from the frame, which is not actually the frame, but the smaller test file, into destination, which is the wrong size. Let's do that. And then we're showing destination in a tile grid on the display. Okay, yeah, let me just do that for now. We released the display a while ago, so I need to reset the device if I want the display to get initialized again, which I do for a moment at least. This will fail actually because 50/50 is outside the bounds. We need to change that before we run it. The way I'm doing it right now is not using CodePy, but instead just importing these other files because I keep switching between which file I want. And ideally, I'm trying to get to the point where I'm iterating more quickly over a smaller section of the problem to try to get it worked out. Let's just do, I mean, we could do 3 if we wanted, really. Let's just do all 3, I guess. 0, 0. 11, 0, and 21, 0, which should be the 3 colors. And I believe those are going to print to us in the 565 color space. Although I have set it to swapped in the tile grid, which is going into effect how it shows on the display, but not going to affect the bitmap, frame bitmap, nor what gets printed here, nor if we were doing the saved pixels, which we aren't currently, but if we were, the tile grid would not be affecting that either, unless we were saved pixeling the display instead of the bitmap directly. Might be something to think about, although I think we want to get to the point where we do the bitmap directly. Okay, we have the display, we're in the REPL, we're gonna run this one, blit test. Alright, there's our 3 colors. None of those are the same color we saw before, which is a little bit suspicious. Display is very messed up. Maybe what I said about this not affecting it was wrong? Also, I must say, for everything I say during this stream, it comes with a huge grain of salt, because I'm trying to discover this stuff, and I'm saying it out loud as though it is a fact sometimes, which is not always the case. It's sometimes more of just a question. That has like weird lines in it. I think we got... Make it bigger. So display is fine. I'm not entirely convinced that's the right format. It's on mode RGB. Saves as BMP. So it wants to default itself again to this one. Those are both the same size. RGB one layer. RGB one layer. Color 8-bit gamma integer. Color 8-bit gamma integer. Color 8-bit gamma integer. Yeah, I'm very confused by this because I was loading this image and it was looking correct. Although I'm showing dest. Let's get the photo tile grid. Actually, I think it's because of... This doesn't make sense for that either, though. Alright, I want to show the frame also. This one's much bigger. This one also Colors are all the same color. Okay, so yeah. Okay. That actually looks correct. Like, correct, I think, even. Yeah. That actually looks correct, like all the way correct. Which is with this, which is what it loaded from frame. But smaller does not work. And produces weird staticky stuff. Alright, let's call this frame TG, which is from the frame bitmap, which we'll also just say has got that. Let's do that. Let's not do that. So we're putting the frame tile grid into the main group to show it, not the one that we blitted. That is still staticky. Has weird lines in it. When I open this, it looks correct. But this 24-bit color, 24-bit color. Okay, so we're showing the frame tile grid currently. So if I'm doing this, we have lines, but if I just switch back to this, takes longer to load because it's a bigger file. That's all correct. All the colors look correct. So frame RGB loads and looks perfectly correct. When I do it on this file, but not when I do it on this smaller test file. Something about this smaller test file is different. Okay. We're going to delete that. We are going to delete trash. copy this. I'm going to copy it in my file browser rather than in PyCharm, which I think is where I pasted it last time. I'm going to update this to be that file. Get the same thing. Just try changing these things and see what it does. So that looks the same to me. Those numbers look the same to me. They're still the same, and that's still looks the same to my eye. Okay. I would really like to get to the point where these both behave the same so that I can start working with a smaller file, but I don't know if we're going to get there, I guess. I don't get any choices here. There's profile from disk, which is interesting. Maybe there's like a way I can specify something. I mean, one thing I'm worried about is the way this keeps going to 32 bits. I don't really understand why that's defaulting there. I'm not sure if it is doing it correctly or if there is a way to check on that. Kind of suspect it might not be doing it correctly, but I don't know how to check. That works successfully. Those numbers are the same numbers, but in a different order, which is fascinating since I didn't really change the order. I have this weird deja vu like feeling of running into some similar stuff like this, and one day floundering around on the internet for a while somewhere deep in the bowels of Stack Overflow or something like that, and finding something that said that maybe GIMP either said or implied that GIMP could potentially change the format that it's saving your color in based on the size of your image in order to like optimize it somehow for disk space or something. I don't know all the details. But I can't really think of much besides something like that that would really account for what I'm experiencing right now, which is basically this big one drew correctly. This looks correct on the screen. All the colors are the same on the microcontroller as they are here on the PC. But the small one, that's not the case for. And I exported both using the same configuration, so they should kind of, I think, work the same way. So that one has started to go pear-shaped, and in a way that makes a lot more sense. Let me get the whatever it is. This is actually worth showing. I didn't really intend to be doing too much on the display itself. But okay, so they're angled, right? They're like trapezoidal, which is, I guess, the effect that we're getting on the small one too, but it's a lot worse on the small one. They get even further angled, whereas this one, they're like only kind of angled. I mean, that makes it feel like we're close, so let's try slightly bigger. It's like medium small. That one's worse. That looks more like what the small one looks like. So 240 worked. 240 by 10 worked. 63 by 10 kind of got close. It was legible, but angled. 89 by 10 was worse. 30 by 10 was even worse. Is there any reason to believe that 64 by 10 might be somehow magical? 63 looked pretty close. Do I even trust the results of this testing, though, knowing that I am randomly getting... It's still 89. $64. Oh. Or copy, paste. So 64 is indeed magical and works. Hmm. But it's not like at least 64 because 89 failed. So 240 width works, 64 width works. 64 is a power of 2, which makes it pretty magic, but 240 I don't think is, so I don't know. 89 and 63 are both even, I mean odd rather, and they both failed. 64 is even and it succeeded, 240 is even and it succeeded, but 30 is also even and it failed. So, I don't know, but I do need to run to the restroom, so I'm going to do that, and I'll be right back. Back. Size thing is weird. I don't know what that's about. I don't know what to do about that. I mean, ultimately, I guess the thing to do about that is probably try to isolate it into a small self-contained reproducer and then file an issue. But that's very weird. I'm going to try to stick with this one for now, though. So we ended up at 64 wide. Let's make that 64 wide. That's printing those. We are currently putting frame into there. Let's actually put dest into there. So we're going to blit from frame into dest the entire thing. Should effectively look the same. Cool. All right, so I can blit from my loaded 888 BMP into my destination bitmap, which is a 65535. And that is working. So what I want to do next is we want to initialize SD card in this. This is wrong still. Alright, I don't know what this part does, truthfully. Doesn't seem like it does anything. Because I changed that and it doesn't change the output, which I would expect it to if it did what I thought. But it's not, so it doesn't. I don't know if it does anything at all. If I'm just using it wrong or what. Not sure how it's figuring out. I'm not sure how it's figuring out to do the conversion correctly, truthfully, but that's alright. I don't necessarily need to know right this second. It is loading and blitting. We want to get the SD card because we want to save at the end. Image BMP. Let's call it edited small. Let's start changing the name here to small. We want to save dest. And I do want to use that swapped color space, even though I think that's going to make our image look wrong. But then we'll go back and look at this. Should have printed at the end. All right, that one exists and it's 2K. 2K is not 0, which is good. It's not getting any bigger, so I think it's probably done already. Just gonna click, gonna download. Okay, and that is actually what I expected, which is nice for once. So we get beige and green and bluish. The beige and the green, though, should look familiar from here, and the blue actually would be, where's zoom? The blue-ish would actually be filling in the middle here if we had not done this, which allowed it to skip source green in the real file, which looks like blue when it's displayed through this wrong color problem we're having. Okay. We have a much smaller test now. And it does output the same problematic color thingy. So what we can do now, though, is I want to try to... So obviously, if we would not use this... I was about to say, obviously, if we do this and then make a point about what it might do, but let's actually just test it instead of that, because clearly I don't know. Maybe I have a bug in the way that I'm doing the color converter save pixels. Bump the number. I wish I could just go to the page also and not download it. It's getting returned as a download though instead of a page. Be nice to be able to just F5 instead of downloading this a million times. But yeah, it's a good thing I didn't just make my point as to obviously how it would work, because it does not work how I thought it was gonna, which would have been that 888 would, I would have thought, made it appear correct. That didn't happen. But the truth is, 565 swapped. That's what we want. That's what it's gonna be. That's what it needs to be in order to copy the JPEG correctly. Whatever solution we end with, we need the 565 swapped to make it come out correct. So I added this in. Let's take a look in Bitmap Saver. One thing is I do need to still go back and get the better code in here for this. So Okay. So it used to not work with color converter. I've added basically the elif that says if the palette was actually a color converter, then we're going to do some different stuff here. Right now what it's doing is taking RGB 565, converting it to 888. And it's doing that because here, it's effectively taking 888 and saving it into this, whatever this is doing, I don't know. Saving it into the buffer, saving it into this maybe? No, saving it into this. Saving it into this. This, though, I think is wanting to act on RGB 888. The reason I think that is because it's got for loop with 3 and it's got an 8 right here. This part of the code I didn't change. And so I think what this is doing is all of this is new. So in the old code, in the existing code, this would have gone to the palette and it would have looked up the color in the palette based on what the index we found at this location was. So we're getting the index of the pixel, the int that's actually stored in that pixel's XY coordinate. We're looking it up in the palette. That is then getting set to color. So that's going to be a hex color. You know, basically, because that's what palette returns to you is like 0x, you know, FF0000 for red or whatever. And so that's the existing code, and then it goes and it takes that color down here and it does this 3-iteration for loop that's bit shifting 8 bits at a time. And it's not shown in this one, but the JPEG would actually look correct. So the JPEG, it doesn't have a palette either, really. It doesn't use this. I mean, it doesn't use this, so. Okay, so the road I was going down to try to solve this is I was trying to modify inside blit in a very kind of haphazard way to just shift the bits around so that if you left all the rest of this code the exact same, you would end up with the correct colors here. And then ultimately, you know, my idea was you would be doing something like this, true false, to enable that mode or not. An even further extension of that might be if you could pass something like this into blit where you could actually give it a color converter. this would be, I think, more particularly useful if color converter could convert to different color spaces more. It really only converts to 565. It doesn't convert to anything else. It converts from a handful of different things, but not to more things. So, but if I could just do the true false thing, that would kind of get us enough, I think. Although I don't know that it's the correct solution to the actual generalized problem, it would get us enough. I think. And so the way that I was trying to do that, to modify blit so that that would work, was I thought the problem was that we ultimately are wanting to end up in this color space. And my theory was that we were in the 565 non-swapped color space. So I was trying to write code that would swap it. And I failed to do so. Or perhaps I did so correctly and that was not the real problem. What do we want to try next, though? So I think we want to... So part of what makes this a little bit tricky in my mind, a little bit more confusing to me, is that value here, so this is inside blit in the core. This is a uint32 value. But we're not using colors that are 32 bits. So I don't know how it's using that 32 bits really. Okay. Let's try this. Let's turn this back on. This is in the core. This is going to print each value. It's going to print each value as it looks them up, as it goes across that pixel while it's blitting. Surprised we didn't mess up the SD card. Didn't get messed up even though we had the display running. Which is cool. We were writing a very small file. I wonder if that helped. I think we weren't trying to modify the display while we were writing the file either, which probably helped. Didn't work. That's on. So the device totally thinks it's in bootloader mode. It's got bootloader on the screen. Had the LED for bootloader. Computer did not see it. There we go. Okay, I just double reset again. Goes back there. All right, so this is going to function the same, but it's going to print some values now. And I think what we're going to do is change the blit to not blit the entire 10 pixels tall. Instead, let's just blit 1 pixel tall. So we'll still do 30 across, but we'll do 1 tall. So we should get 10 of one color, 10 of one color, 10 of one color, and then everything else of the last color. 64, I guess, should be 34 rather, should be left. We also still have these ones printing. Okay, so blit right here. No, blit right here. Let's say x1, 0, y1, 0, x2, 30, 29? Well, 64. But should it be 63? I don't know. Y2, 1. That should be 1 tall and 64 wide is my intention, although I don't know if that's off by 1 there. Okay, let's take a look back. So our Python code printed 0, 0, 11, 0, and 21, 0, and those were 38BE, D01F, and 70E, which is 70E I recognize as this, which was our green. And that was 21.0, which actually was correct. So our Python code is seeing 565 color space values that are correct. I don't know why that's not, like, visible. This is... This is in percents for some reason, not pixels. Okay. 1 by 1. 21. Green is correct for this. Which leads me to believe most likely pink, which is... E01F, yes. And then 0, 0. Which will be blue. .38DE. I got BE instead of DE, but that's really weird. Okay. But more or less, pretty much those are correct as 565 representations of our actual 888 colors that actually appear in our image. And those get printed directly from frame BMP. So inside frame BMP, when you access those colors, those are working, you know, air quotes correctly. And then so blit, inside blit, it's going to be accessing those same pixels in order to put them into the destination bitmap. Which is ultimately in this color space, and I want blit to do the conversion for me. So that's where my mind was. I think what we've got is is 565 values, and I think what we want is 565 swapped values. So to that end, I wrote C code that swaps some of the bytes around. In full disclosure, I did not actually write the code. My friendly Microsoft Copilot helped me quite a bit with this. Could be part of our problem, let's be honest. So this code takes a uint32, which is what our value is, which is still a little bit odd to me because we only have, we know our color is in 16 bits. So, but we're using a uint32, which I think is 32 bits. So our variable is bigger than our value. But I guess it's big enough to support 888, which would be 24 bits, even though that's still bigger than, 32 is still bigger than that. I guess it was chosen to support that, but I'm not sure. So we've got 32-bit value. We are breaking out in this code here 4 8-bit ints, calling them byte 1, 2, 3, 4. And then putting them back together into a new uint32 called swapped value, and we're changing around the order of some of them. And in particular, right this second, right now, it is leaving byte 1 and byte 2 alone. And it is changing the order of bytes 3 and 4. It is swapping bytes 3 and 4 because it's doing 4 first and then 3. So we're not doing anything to bytes 1 and 2. We're leaving them alone. 1, 2 stay in the same order. But remember that our color is actually only 16 bits and our thing is 32 bits. So 2 of our sets of bytes are useless, right? Not used. I don't actually know for a fact that it's... didn't know you were live streaming. Yep, we're here. I didn't start too long ago. I don't have the counter pulled up. I don't actually know how long ago it was. Yeah, we're deep in the color space weeds for sure. This one is... We're deep in the weeds for color spaces. So let's run this one. It's swapping bytes 4 and 3 around, which you know, sounds like it would take us from a non-swapped to a swapped in my brain. This is in place because it's doing write pixel, and instead of just sending value unedited, it's actually saying swap first 2 bytes value. And it's called swap first 2 bytes. We're actually swapping bytes 3 and 4, but that's fine. All right, let's go to bootloader. Copy that build to it. So this would ultimately not be the solution to just randomly hardcode this inside of here. We would obviously want the Boolean or some kind of thing to do this for us to indicate when we want to use it or not, but I am just trying to get it to output the correct colors, and then maybe we could go back and make a mechanism that enables it and disables it. Ah, it's too fast. I shouldn't have clicked back to here yet. MP core coding, anytime I see MP or Q string, I immediately knew whatever doing is over my head. Yeah, it's, strangely enough, I am with you there. It's kind of over my head too, but I'm here doing it. We're making our way through it. So it's interesting to kind of plow through and figure it out as I go, honestly. Alright, so let's try this again. Let's run this one. Let's bump that to 2, so it's at this point only blitting one row. I mean, do I need to do that? I don't know. Maybe we should just split the whole thing anyway. Well, okay, I did that because of the prints, actually. And the prints do look normal, right? These look like what we expect because we got 10 of this, which was the same first number that Python printed. Then we got 10 of this, which was the same second number that Python printed. And we got 10 of these, which was the same as the third number that Python printed, and then we got probably 34 of these. But I'm not going to count, and it doesn't look like this thing adds it up anywhere that I can see, so. One thing that maybe we should do is print the swapped value. You print the swapped value? We should probably print the swapped value. But I don't know how, I don't know if they look correct or not. All right, I do have to run to the restroom again, so I'll be back again. Okay. I almost want to print the bits values if we can, like a binary representation of this. And I do think we want to also print the swapped version. It's unfortunate. Our two choices are create a new variable. And I guess we could print it from inside swap. Maybe that's what we do. I'm gonna say our two choices are make a variable to hold that, print it, and then put it into here. And then effectively we don't use that variable again. Or the other option is call swap first 2 bytes twice, which is also not the best. Although I have no idea how fast or slow this is. Maybe it's really fast. Seems like it should be right. It's bit math. It should be pretty fast, I think. But let's print it in here. That way we get both. So we'll get hex value, then we'll get swapped value. Let's make another new build and reload that again. Whoa. Sorry if that was loud. Don't click back yet. I'm gonna wait for CircuitPy to come back. Basically, if I don't focus PyCharm during the time when we have the boot drive showing, then when I come back to it, the code file will stay open. But if I focus it while the boot drive is active, when I come back to it, it will like recognize that this file is gone and it will close it. All right, so we bumped that. Everything else is the same. Let's save it. Let's run it. I'm not having the same problem with the SD card right now. I suspect it's because we're writing such a small file and not updating the display, I guess, while it's happening, it seems like. We'll add a little bit of sleep just in case, I guess, but it doesn't seem like it's been a problem. Okay. The good thing is that that's actually pretty fast. So let's look at the results. One of them's on there. It's very hard to see, but and that's using the tile grid also. It's not the part we care about. Really, we care about the way this bitmap comes out. And it came out as the wrong colors. So it's red, pink, and green. Whereas blue okay, now maybe that's closer than I thought earlier. That might actually be closer than I thought earlier. So red and blue are wrong, but pink and green actually look correct. Let's do a bigger one. So we had before 38BE and we ended up with BE38, which is swapped. To me, that looks pretty swapped. It didn't end up being what we wanted for that one, the first one. But The other ones did, actually. So D01F was the original value, and 1FD0 was the swapped value. And the output file has what looks to me like the correct color for pink and green. I'm gonna clean out my downloads folder. FB00, so it's not the exact same, but it's pretty close. Now, yeah, we don't have the skip source, actually. Let's put the skip source in it. Let me catch up over here. Looks like blue and red are swapped. Yeah, I think something like that. If there's no blue, then pink is closer. Actually, it looks like the absence of blue. The pinks are exactly the same. One's almost purple, the other's more fuchsia. I'm just going off the colors I'm seeing on your monitor, not the values. Yeah, and the colors, yeah, there's all sorts of, like, my monitor plus also OBS plus the streaming compression and everything could do all kinds of tricks to the actual specific colors. Let's do a bigger chunk, and let's also do the skip source. If skip source works, then it will skip green. So then we'll see only red and pink. And then if we can get red to be fixed into blue, we're almost there. I'm looking for convert photo, and then we want this, and we can take that and drop it in the blit here. We don't have that thing, so we need to make it. We don't have that. Okay. I don't know if that's... So we got FB00. I don't know if that's going to turn out right, but let's just try it like that and see where we end up. Let's set it back to doing the whole thing. Which we can do by doing that. All right, and this will be a lot slower because it's doing a lot more pixels and it's printing each time, which is actually pretty slow. Okay, so we got like beige and green and black, so or something. It didn't bump the number again. We got, okay. I shouldn't have looked at the screen, I guess. I don't care too much, I guess, what's on the screen right now. Here, more what's in this file, which is we did get black where the green was, but that's because the transparent actually worked. Okay. So, red and blue are swapped BGR RGB. BGR RGB. Red and blue swap. So, in addition to this, we need to swap blue and red. But blue and red are their 565 counterparts. So we are not going to be operating on clean bytes of 8 bits. We're going to be operating on 5 bits of blue and 5 bits of red, and we want to swap where they're at. Of our 32 bits total. Oh goodness. Okay. C print U int 32t in binary. All right, let's try the GPT and see what. Hey, my page is gone. There you. All right, and now we're going way into the waters here. Straight to writing C code to try this out. Print binary value. So this is gonna make it so that I can try some stuff without needing to build CircuitPython. We actually just want to call print binary. These are going to be mad. Swapped value, new value. Let me also take the code from currently in here this as this because it might be different. Save this. Build with C. Run. Okay, so the numbers used here use the full 32 bits. And we can see from the hex outputs that it is swapping those last 2 bytes. So theoretically, we could see that same thing by looking at the last 4 bytes here. Those should be not 4 bytes, but for 8 bits, 1 byte. 4 nibbles, I think, right? But what we want to now do is within the last 16 bits of this, within the last 16, we want to take the first 5 and the last 5 and swap them. This should be a smaller number. We have less bits, hopefully. Well, yeah, less bits that are actually mattering, I guess. It's not a smaller number, but it's... First 16 bits don't matter. Can I... That's gonna mess everything up. I don't know what put char does. I think this is gonna mess everything up though. The meeting, yeah, meeting for next week. Some backup here. Do this later. I think, does this get merged? It'd be nice to actually grab this in the one that we're building. It did get merged, nice, okay. Try to put a space after that, just to split it up after 16 digits. Not sure if it's gonna work. No, doesn't like that. I mean, I could just get rid of that digit, I guess. The digit at the 15th index. At index 15. Which means 1, 2. 14, 15, 16. I actually did that wrong then. 14? Doesn't make any sense. Oh, it's counting down, I guess. Interesting. Oh. 4, 8, 3, 4, 8, 10, 12, 14, 16. Now we have 17. I'm gonna go the other way. Two, 3, 4, 5, 6, 7, 8. No, why? 3, 4, 5, 6, 7, 8. 2, 3, 4, 5, 6, 7 dash. So then we should have 16 digits here. 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 14, 15, 16. Okay. Okay. This was only just to get it so that it's easy to look at the last 16 bits here. And so what's happening right now is the first 8 of those last 16 are getting swapped with the last 8. That goes to there, and this goes to here. But on top of that, we want to now take the first 5 and the last 5, and we want to swap those also. Whew. And we do that by... Okay. I wanna, let's see here. Let's try, same thing. Let's call this swap R and B. That's gonna take a value. It's gonna return a value. Yeah, let's start just like that. Then let's say that we want to make a uint16t for just color equals value $16. That's not going to be right. Whatever, let's get something down and run it. Because the truth is, I don't know what's right. I'm not going to know what's right until I see the output and try changing it. printf color. And then print. But color is uint16. So it's not going to work for print binary. So I'm going to make print binary 16. I'm going to make that 16. I am going to make that 15. We're gonna get rid of the if statement. That will be 16. And I think the rest of that should pretty much work. Color. So I don't think these can be out of order like this. I think because that uses that, it needs to have this come first, probably. Original value is wrong. That should be color. Nice. Okay, that built. So let's end this. Okay. We haven't run swap R&B yet. Okay. So we just say, let's just say another one, uint32t final value. You could just declare it above at the very top. You repeat the type of the function. Yeah, sorry, that's what's done in header files. Yeah, sorry, the truth is I don't really know C, is the truth. I don't know what you mean. Yeah, flat out is I'm just very noobish on C altogether. I'm really trying to just hack this together as best as I can. So I think in CircuitPython, it does have H files. I did actually have to add that to the H file. But in this one here, I don't have an H file. I just have a C file. And I think that's okay for now, hopefully. I won't ultimately need all of this stuff inside CircuitPython. And I will say also, while I don't really understand what you mean, I do appreciate you trying to help me. All right. Hopefully it's not too frustrating to watch me flounder on this, because it sounds like you probably have got a better idea of what I'm doing at this point than I do. So let's try final value is equal to the RGB swapped one, this one right here, of the new value. You just repeat void, print that at the top after the includes. That's what it means. I gotcha. Okay, so we could basically have that. In order to be able to do it out of order, we could do it kind of like the H file, how I did before. So if we had that there, then theoretically we can drop that back up here, I think is what you're saying. Let's try that. Yeah, nice. Okay. Thank you. I appreciate that, my friend. Hell Rutan. Yeah. With this, you can use the functions before they're defined out of order. Nice. Thank you. Small bits of knowledge at a time in C for me. Let's see. Okay, so final value swap. So that is, it is printing. We got all zeros though. We got the first, I think we got the first half, not the last half or something. Okay. So uint 32t into 2 uint 16t. This is probably super basic stuff, I know, but just not a language I'm got experience with. Ooh, I don't know. Why is this? Oh, it's like saving them into there instead of returning. Right, okay. Okay, maybe we don't need that and at the end. So we've got a value shift 16 for high part, and then we've got a low part, which is a value and that. So maybe we shouldn't be doing this, and then that is going to be the high part. I don't know if the high part is the part we want, but let's just run it like that, actually. Yeah, what I'll do is we'll swap it to the other one if that ends up being not it. Which it doesn't look like it is, because we still have all zeros here. So then value ampersand, however many Fs that just said, 4 Fs, least significant bits. Those are the ones we want then, maybe. Does that get us our actual bits? Yes. Awesome. Okay. And that's 16, right? Let's just make sure. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 8. Awesome. Perfect. That is 16 bits. Those are the bits we want. Okay, so we get our color. We should maybe still like break this up even. I don't know. This is probably horribly inefficient. I think what I'll do though is we'll say uint 16 color. We'll say uint 16. I'll just call it pad, I guess, for the first half. And that was a shift 16. Yeah. So pad, we'll eventually use that pad because we're going to want to bring this back together as a uint 32. But for now, we've got our color. So we can try to split up our color. We want 5 bits, then 6 bits, then 5 bits. And I guess I could store them in bytes, but I don't know for sure if that's going to work. We shouldn't call them RGB, though, because we're in the middle of trying to swap R and B. So let's call it first, second, third. Not the best, but whatever. Okay, first, second, third. I catch up here too. Seeing voids and printfs in the same function makes me twitch a little bit. It's just weird, yeah. Correct me if I'm wrong, but that's because somebody wrote swap and not unswap for i65. You mentioned something like that in Discord the other day. CPython is a weird mashup of C and Python. Looks so weird. Yeah, agreed with your last part there. That's because someone wrote the swap function but not unswap. Yes, I think that. So I still think we're trying to get from. We're trying to get from unswapped 565 into swapped 565, I think. And color converter only goes one way. We are making use of that one way when we are decoding our JPEG. And then also again when we're saving the pixels of our of our bitmap at that point. But this bit here is kind of doing the I think it's kind of doing the reverse for us. Now, as I prefaced before, I don't know if you were here, take everything I say here as, even though I'm saying it as like, this is how it is, the truth is it's like, this is how I think it is, and I could definitely still be wrong. Because I very much don't really know that much of what I'm doing. But slowly but surely we're making it through. So we have pad, we have color. What we want to do is get 5 bits at a time. So I want to get the first 5 bits with this, which is not going to be like this. So given a uint 16, how can I get the first 5 bits? Can you please show me the C code to get the first 5 bits of a uint 16 T? Gonna have to start a new chat here pretty soon, probably. Run 6, but track the first 5 bits. Bits from 11 to 15 to 11. You can do this. So it's saying, so we go shift them by 11 and then we AND them by 1F. And that's gonna give us the first 5 bits. So first would be shift them by 11, AND them by 1F. But we don't want value, we want color. So theoretically, that's going to be the first 5 bits of our color, which is kind of representing red, but kind of representing blue, depending on how you look at it. We want to get the second part, but that second part is 6 bits. Those bits are through from bit 10, 10, 9, 8, 7, 6, 5. From bit 10 to bit 5. From bit 10 to bit 5. Get the 6 bits from bit 10 to bit 5 of a uint 16T. To extract 6 bits from bit 10 to bit 5, you can use bitwise. So that's a shift by 5 and then an AND by 3F. Shift by 5 and an AND by 3F. Okay, and so we want the last 5 bits now, which are going to be, I think it's a no shift. So let's see if I'm learning here. I think it's a no shift, and I think it's an and I think it's an and by this again, 1F. These do need to be color, not value. So let's do that. Let's ask our helpful, friendly Copilot friend here one more time. We are on 8 of 10. Let's say one more time, can we... to get the last 5 bits from a uint 16T. We'll call it the last 5 bits. Should we do, is it going to understand parentheses like it gave to me, right? Because it said like, originally it said like first 5 bits and in parentheses it put this. Is it going to understand that? That would be bits 4 to 0. 4, 3, 2, 1, 0. Yeah. bit 4, 2-bit 0. I got it. I'm learning. He's learning. Okay. First, second, third. Now we make a new 16-bit Yeah, we make a new 16-bit, but it's gonna be weird because we only because all three of these are 8. Oh, I don't know if it's gonna work. Let's try it. Kind of don't think it's gonna work. Shift. Maybe the shift is gonna make it work. All right, we want a new one of these. New uint 16. We want that one to be modified color. And that is gonna be some stuff like this. So we're gonna say, we are gonna say third, shifty shifty. So up here, we're putting back 4 bytes together to make a uint 32. And I want to do effectively the same thing, except we got 3 bytes, not 4, which doesn't add up properly, but that's because our 3 bytes actually represent smaller numbers. 5 bits in the first one, 6 bits in the next one, 5 bits in the last one. We want to get those 3 back together. So, but that's actually, it's actually taking, it's turning them into 16s, not 8s. Which is fine, it would just use more blank space. So when we're putting back together 32, each of our bytes, we're using all 8 bits of each of them. So on the first one, we say byte 1 shift by 24 because that's the remainder after we have taken the 8 bytes from byte 1. So down here, we're working with 16. We want to shift. We only want 5. So if I say third and I shift 11, and then if we second, should be shift something else, and then if we first by itself with no shifting, is that gonna work? I don't know, probably not. And what would this one be? Use OpenAI ChatGPT to help write a driver, so I'm not opposed to using AI help anymore. It works-ish. Yeah, I'm with you there. It's kind of like, if you can ask it the right things, it can give you the right answers, but it's also tricky because if it's right on the edge of your knowledge, it's tough because it can be confidently wrong in ways that you might not catch. Which even early in this chat, it did not really understand me correctly, but it told me that it did, and it gave me code that did something that was actually different than really what I asked, and kind of how I thought it explained it was doing it, but I did eventually catch on. I mean, I guess this is probably 5, right? Because, so we started with 16, we used up 5 by putting that in, which we minused to get to 11. We want to minus 6 more for that. Yeah. Try that. Okay. Now let's print binary 16, our modified color. Okay, so that's our color. That's the bits of our color. So did we take... Right away, one thing for sure that didn't go right is... So the last 5 bits are right here. And those are 1, 1, and then 3 zeros. But we got 1, 1, and then we got 0, 0, and then we got a 1. We actually wanted a 0. For the last 5, looks like we did actually swap pretty well. It could just be a coincidence. We could still be off by 1, and we just got lucky. Okay. I have 3 uint 8 t's The first contains 5 bits. The second contains 6 bits. And the third contains 5 bits. Can you show me the C code to combine them together into a uint 16t? All right, I was off by 1. I was literally off by 1. That's a 5, not a 6, but 11 looks like it was correct, and the last one doesn't do anything. So it's casting also, though. It is casting? Maybe that, I don't know if that's important. I don't know if that's important. That might be important, but I was just off by 1 here, and I think that's going to do it, honestly, because the output I got felt like an off by 1 error. Okay. Yeah, that's it. So first 5, 1, 0, 1, 1, 1, 1, 1, 0, and then 3 1s is now last 5. And then the last 5 was 1, 1, 3 zeros. That's now been swapped to here. First 5, 1, 1, 3 zeros. And then middle 6, which is 1, 1, 0, and then 0, 0, 1. Those stayed the same. Okay. Should not probably be that hard, but we made it, and it feels good. If you're off by 1, then C. Grover's advice. Oops, how's it going, C. Grover? Sorry, I missed you there. I haven't looked back at the chat in a minute. Shift the second by 5 to put it back where it was. Yeah, you ended up, you were right. I didn't catch on quick enough, but that is correct. We wanted to shift by 5 on the second one, it turned out. Okay, so we now should be able to do what? I think take this. Let's get rid of some. We don't want to print everything though. Technically, we could maybe just return. Is that, I don't know if that's bad or not. I'll just do return modified. It's extremely satisfying. Watching someone figure out a bit shifting and confirming the binary is far more satisfying than I thought it would be. Yeah, I hear you there. It's like such a small detail of like, yes, the 1s are in the right spot and the 0s are in the right spot. But yeah, it feels very triumphant when you actually do get them in the right spot. All right, so let's take this. So that takes a, well, okay, hold on though, because that's modified color, which is a 16. We're not done yet, actually. We need to put that back together. Hold up. Let's slow your roll a bit there. Okay, so we want to take that, what we now know is a correct 16T. We need to get that back into a an actual uint32, which will be return val. That is going to be, we take our pad, we shift by 16, and then we OR the modified color, which should be also 16. Okay, let's make sure that works. Let's actually keep all of these back on for now. Whoops. Let's do a print binary 32 on the return val. And then let's return that return val. I'm surprised. Did I not have it? I never had it. Did I have a return statement modified? I guess we return this. I don't know. I'm surprised this wasn't mad because we either were not returning at all or we were returning a type that was different than we said we were. Apparently C is a little bit more resilient than I thought. Okay, print binary return value. So that should be the same value as this, just with 16 zeros on the front. Missed two of those semicolons. Okay, so that's actually the same thing we had before, which we did learn the fix to. Just to put this up here. Nice. All right, cool, yeah. I think we're there. Okay. Spent a few years writing machine language. I can occasionally think in binary. Nice. Yeah, I've never been quite this slow before. This is my first experience being this low level. Never had any interest in actually learning binary to the point of being able to read it without a converter, but I'm starting to see why people are attracted to it. You can do some interesting stuff with it for sure. Like at the end of the day, you become a bit of a data manipulation wizard in a way. If you can learn the right stuff about it for sure. All right, so that is working. That is now at 32. So let's take this whole function. Let's get rid of all the prints for right now. Then we can take that whole function. Let's put that into the core. And we would like that to be here. Swap R and B, we need to declare it. All right, and unfortunately, I've been drinking a lot of coffee and water. You'll have to forgive me, but I gotta run to the restroom yet again. Okay. Okay. Can Copilot optimize the resultant function code as well, perhaps more friendly than Pylon? I do not know. It may be able to if you asked it kind of in that vein, as opposed to more, you know, like I asked it, just give me code that does this. If you then turned around and gave it back that code that does this and asked it, could you optimize this in, you know, whatever way you have in mind, it could. My suspicion is that it probably could, but I don't know. I don't know that for a fact. I haven't actually tried, and I'm sure, like with a lot of things, it's probably very dependent on the actual code. Simple stuff it might be better with than more complex. Okay, so we've got to swap R and B. We've got to swap R and B. We want to go and use it. So we've got our swap first 2 bytes. We want to now swap also. So we swap the first 2 bytes first, and then we swap the R and B on that. So we do both of those. And that should make it so that the colors come out correctly. Now we do still have the problem that this is just randomly hard-coded inside Blit, which is going to be bad if we actually were to use the JPEG right now. It would get all messed up because this code would affect it as well. We don't really want it to because that will mess it up. But if we eventually make a Boolean inside Blit that says, like, do you want to use the swapped mode or not, basically. All right, we are just still printing a lot. We could probably turn off some more prints, maybe would be an idea, but that's all right. Let's just see where we're at. Okay, I came back too fast, which is why my file closed here. Wait for the... What do we actually have right now? So we are doing the full 1. We are doing skip green. We are saving. Let's bump to 3. Well, let's give it a try. All right. Edited small 3. No. So red has swapped with green. We're technically still printing only the swap first 2 byte. Our green still got treated right, which doesn't make any sense to me either. Man, I felt so close, but obviously we're not there still. I don't get that output. Yeah, I took out a bunch of the prints though. Gotta head out now. Fun thought process. We'll have to catch the remainder on the stream later on demand. Yep, take it easy, C. Grover. Thanks for stopping by for a bit. Let me do something here. I'm probably gonna wrap it up here pretty soon as well. Unfortunately, still not quite. It's not working how I want, but I think I'm getting close to out of steam for the moment, truthfully. All right. Yeah. So this was our one where we swapped. So the last 5 came over to be the first 5. The first 5 swapped out to be the last 5. And the middle 6 stayed the exact same. Which looked like what we needed because we expected a blue color and we got a red color. So that kind of made sense. But now that we've done that, instead of turning our red into a blue, it has turned our red into a green. And it has turned our pink into a blue. Pink presumably should not have been affected because swapping the red and greens shouldn't really change the pink that much because pink is kind of like full blue and full red. You're gonna head out too. Great stream. Yep, take it easy, dude, Evan. Thanks for stopping by as well. Yeah. Yeah, got a lot of nice looking images in that folder. Yep. At least they're colorful and pretty. Give them that. All right. I mean, this tells us the bit operations did what I wanted, and then when we put it into the real world on the colors, it turned out to be not what we needed. So we were actually closer when we were here. Let's do this without the skip source. Just do it straight up. Copy from framed dest. That's gonna create edited small image 3. I wish I would have I wish I would have changed the name of that before I did it, but oh well. So we got, because that was, this one was with RB swap. I don't know why we got it 0 byte. I guess because I just renamed it. Now it can't find it. I mean, that's close. That's almost there. Pink and the green are correct. The red is supposed to be that shade of blue. I mean, I guess you could argue the pink is not perfect, I suppose. I mean, it's kind of like a brighter pink, I guess. F700CF. The original is darker, D400FF. But the original is 24-bit, and we get clamped into, you know, less. So yeah, I mean, that's what I thought. That's what it looks like, certainly. But then I just went and wrote the code to swap the R and the B values and verified that that seems to be doing what is intended. That's what this stuff back here was, basically. So this was the pre R and B swapped, and then this was the post R and B swapped. And R and B are both 5 bits, so the first 5 bits got swapped to the end, and the last 5 bits got swapped to the beginning. And then technically our color is only 16 bits, but it's also stored in a 32-bit integer, so we've got the rest of the empty space there. So we could kind of confirm that we were able to swap the last 5 and the first 5, and that did successfully work. But the output that we got was this. Which green, the far right one here would have been green. That was set to transparent at the time, which is why it came through as black. But our red here has swapped to green instead of blue. So for some reason, swapping the first 5 bits and the last 5 bits caused red to change to green. And I don't really understand how or why, because it doesn't seem like it should to me. And then it also seems to have caused the pink to change to a blue color, which I don't follow either, because I think pink should have stayed pretty much the same. If what we had done was actually successfully swap red and blue, then pink should have, you know, maybe the hue changes a little bit because our pink is not symmetrical or whatever, right? Like we had DF and then FF, or D4 and then FF, rather than like FF and FF. But so you maybe the hue, you know, it shifts a little bit or whatever, but Not all the way to blue. I don't understand all the way to blue. That makes it feel like I swapped red and green, not red and blue. But if I swapped red and green, not red and blue, how come my transparency still worked? And why was green part of what got swapped when what I actually swapped was the last 5 bits and the first 5 bits, when green should have been the 6 in the middle? So I mean, I've definitely run across like BGR versus RGB. I've run across that before, and that, you know, it kind of looks like that's what we've got, but I'm not following because green should have been in the middle. And when we look at all the bits, it works. Looks correct. I think the next step would be to bring in the print binary into the core. Do some print binary action inside of here. And see if inside the core we're getting the same binary output as we're getting in this minimal C file. Because if we're not, then we know that like something's wrong with copying this code in or whatever. If we are getting the same bits printed in the core, then it tells us that either the logic in the operations is wrong, or the assumption that the order of green in the middle is wrong. One of those two things has got to be wrong if we are ultimately printing all the same exact bits when we get into the core as we are here. All right. Green, yeah, GBR, yeah. So it's so weird. I don't know. And I mean, I can stare at this code and I can be like, is this correct? But like, the bits don't lie, right? Like, we definitely successfully swapped the last 5 and the first 5. Maybe we needed to do that first. Maybe we need to... Maybe we need to swap... Maybe we need to swap the first 5 and the last 5 first, and then swap the first 8 and the last 8? Right now we're doing the other order. We're taking the first state and the last state, we're swapping those. And then from our now changed order, we're taking the first 5 bits and the last 5 bits, and we're swapping those, leaving the 6 in the middle alone. If we did those in the opposite order, we get different numbers. So maybe that's what we need to do. But we're so close when we only do half. It's like, I don't know. I don't get why we would be so close when we only do half. All right. I think I'm going to call it a night for now. Set this down for a bit. Come back to it tomorrow, maybe. Thanks for hanging out in the chat. I will be back at the normal time on Saturday. Saturday morning, 10 a.m. Central Time. That is when you can catch me weekly working on CircuitPython stuff. Usually a little bit slightly higher level than this, but this is the project right now, and this is what it's, what we're trying to do. Ultimately, the project itself is higher level, but this kind of nitty-gritty bit shifting stuff is going to get used by that project, so it's where we're at. I'll be back on Saturday. Thanks for hanging out today. I appreciate all of you. Hope you all have a nice day, and I will see you later.